So I want to finish off the lecture slides because there is still some important stuff that I want to cover. Important as in it's relevant to the assignment, and then I'll talk about the assignment specification. Hopefully you've had a chance to look at it since I published it there yesterday, but let's see anyway. So the slides that I'm going to go through are this set of slides here. I've just added a few more slides onto this deck, which I started the last day with you. So we're still on this SNS and more generally event-driven architecture. So these are the slides, and we've talked about SQS, we've talked about SNS, you've practiced it in the lab. And where I finished off the last day was talking about filtering in the context of SNS subscriptions. So if I pick it up from there, really. And now that you've completed this week's lab, hopefully you have anyway, then you've got some practical experience of programming it from the CDK point of view. General idea, as you know, is you've got a publisher on the left, or many publishers really, which is the case in the case of the assignment. You've got different publishers publishing different types of messages, or in the same publisher publishing different types of messages. And your subscribers may only be interested in certain messages. So we want to filter out the ones that they are interested in, or in other words, filter out the ones they're not interested in and don't pass those on. And when we talk about the SNS model in relation to AWS, there's kind of three parts to it. There's the publisher on the left. Well, four parts actually. There's a publisher on the left. There is SNS itself. There's the subscribers on the right, and we know the subscribers can be anything. In this case, they look like queues. But in the middle, then there is the subscription, and it's in the subscription part of this model. That's where we declare that there is that we'd like some filtering to be performed. How this actually breaks down into how it's deployed in terms of resources in AWS, we don't really care about. Probably there is obviously a tight connection between the subscriber and the subscription. But anyway, so that's filtering. And there's there's two ways that you can describe the filtering that you want associated with a particular subscription. You can either do it on the basis of attributes that are attached to a message, or you can do it on the basis of the actual message body itself. And we talked about the attributes approach the last day, and that's what you have practiced in the labs. So I'm going to move on to filtering when it's based on the message body. And typically, the message body is a JSON structure. And so what you want to be able to do is express in your filtering that I only want messages where there's a particular property in the message body that has a particular value or one of a set of values, or its value begins with a particular prefix. That kind of idea. Or indeed, I definitely am not interested in messages where there is a property, a body property that has a particular value. In other words, you want to specify the ones that you want to be denied access to the subscriber, whichever is the easiest to express. Sometimes it's easier to express the ones that you want to allow to go through to the subscriber. Other times it's easier to express the ones that you want to be denied access to the subscriber. So it's filtering on the basis of the message body. And the types of filters is the exact same as the types of filters we saw with attribute-based filtering. In other words, you can specify a string filter. So that would be, you'd use a string filter if the property of a particular body property, its value was a string, and you wanted to express the filtering. The condition might be expressed in terms of what you have an allow list. In other words, you're allowing certain messages where that property's value is one of a set of values. You allow those to go through to the subscriber. Or a deny list. Here you're specifying that if the body property has one of the values in my deny list, then do not let it through to the subscriber. Or you could specify some sort of prefix that you're looking for in the property. And they're the exact same as the conditions, as we call them, the filtering conditions. They're the exact same as what we have practiced in the lab this week, but in relation to attributes, message attributes rather than message body properties. You can also have number filters. We had no example, but it's not too difficult to imagine how they might be useful. This would apply where a body property, its value is a numeric value as opposed to a string, or indeed an attribute value is a numeric value as opposed to a string. And again, you want to specify the conditions associated with this numeric filter. And there's quite a lot of them. There's an allow list as well. So maybe the numeric value can be one of a set of values that you express in your allow list. And you can have a greater than, a less than, between, etc., etc. There's also a third type of filter, which is just called an exists filter. And really what you're trying to express there is, let's say in relation to attribute filtering, what you'd want to express is, well, if a particular attribute exists with this message, you don't care about its value. Once it exists, then you want it to go through to the subscriber. In relation to message body-based filtering, what you would be saying is, well, if the message body has a particular property, you don't care what value it is. If it has it, then let it go through to the subscriber. Or indeed, if it has it, do not let it go through to the subscriber, whichever applies. So anyway, we only looked at string filtering, and string filtering is enough for the assignment, which is probably all you're really interested in, but you have these other ones anyway. Now, to illustrate message body-based filtering, we're just going to use the EDA lab that she submitted there whenever during the week. And I'm just taking one part of the architecture that we built up in the lab. So we had an S3 bucket publishing to SNS. SNS had a number of subscribers. One of them was an SQSQ, and that SQSQ then was polled by a Lambda. Now, in between here, like in here is my subscription declaration, as I was saying. So let's supposing we want to filter out certain messages that go through to the SQSQ based on the message body and a particular property within the message body, and we want that to be evaluated. In this screenshot, I'm showing you the console log from the Lambda on the extreme right, this Lambda here. I'm showing you a console log of the event that gets through to it, and buried within that event is the actual message that SNS passes into the queue. Okay, and as we know now, the message body is stringified, so it has to be parsed. That's okay. But so this is really the message here in the red box. This is the message that we can subject to filtering, because this is the part that actually is passed from SNS through to the subscriber, which is SQS in my case. We don't care about the other stuff. All this other stuff has been added on by probably SQS. You know, it's some extra wrapping that's added on by SQS, or indeed by the Lambda service itself. And so if we parse this, and we know now that this message actually originated way back in S3. It was when S3 sent a message to SNS. Yeah. And when we parse it, this is what it looks like. And so we can see, you know, it's a nested object structure. At the very top is a key called records, and within further down there is a key called S3. And further deeper again, there is another key within the S3 object. There is a key called object, just kind of blocked out there, but it's an object. The key is called object. And within the structure attached to the object key, there is a key called key, and that has the actual name of the file that was uploaded to S3. Now, supposing I want to express a filter that said, I only want messages to get through to the SQS queue and subsequently to the Lambda, where the file name begins with image, right? So how do I express that in my filter policy, if you like? So we need to know the structure of this nested object, and we have to describe this structure in our subscription, because we have to essentially explain in our subscription where exactly does it find the particular part of the message that we're interested in. In our case, we're interested in this part here, but we've got to actually, if you like, we've got to tell the subscription declaration, well, start up here and then go looking for a key within the record structure, look for a key called S3. And within the object associated with S3, go looking for a key called object. And within the structure assigned to object, look for a key called key, and then apply my filter to the value associated with that key. Right. So in general, we want to do some filtering between SNS and SQS, and we want the filtering to be based on the body. And here's my example, as I've just been saying there. Supposing we want to allow messages where the S3 objects key, S3 doesn't talk about files. S3, as you know, S3 talks about objects are the things that we upload to S3, and they can be anything. They can be a file, they can be a JSON structure, it can be any type of file. So generically, S3 refers to them as objects. And generically, the name associated with the object is called the key. Key then actually translates to the file name in our case. I know you know all of that. So here's how we actually describe, and it is quite verbose, but there you go. So what I'm showing you here in the screenshot is I have my topic, my SNN topic declared elsewhere in my CDK stack, and I'm adding a subscriber to it, and I'm adding an SQS subscriber. That's all something we're familiar with already. And I'm specifying the actual SQS queue. So this is a reference to an SQS queue that I've defined elsewhere in my CDK. And then I have various options or various configurations that I want to associate with this subscription. And in particular, I'm adding this one. So this is the option where you describe message body based filtering. It was a different property when we were talking about attribute based filtering. If I just quickly flip over to, in fact, if I go back a couple of slides, back to let's see, is it here? Sorry, no, should I have done that? And the DLQ, no, where did I have it? There it is there. Okay, here's the here's the attribute when you're doing attribute-based filtering, whereas it's a different attribute when you're doing message body-based filtering. Okay, let's go back into here. And so I know the syntax is quite verbose, as I say, but essentially what we're trying to do is we're trying to describe the structure of the message, and we're trying to tell or express in our subscription, we're trying to express how you find the actual part of the message that we really are interested in. And so here we go, records, S3, object, key. And we're using these static methods as well, provided by the SNS SDK, if you like. So this, as I keep saying that, so the syntax is quite verbose, so you've got to be careful when you're kind of typing this stuff up, because you classic problems that you're going to have is you're going to have a lack of matching closing braces. But anyway, so, you know, as I said, as when I showed you the detail of the message body, at the very top was the records key, and the object assigned to that records key had a number of properties. One of them was the S3 property. There were other properties. If I go back, I don't know if we're flicking back and forth, but, you know, apart from S3, which is way down here, there are other properties as well, but we're sort of saying you can ignore all of those. And equally within the S3 object, there are lots of properties, but we're telling it ignore all of them except the object property. And eventually we get to the part of the message body where we actually express our filtering condition. And here's our filtering condition here, which is actually the same syntax that we use when we were using attribute-based filtering. So it looks like, look, it's a string-based filter. It's a matching prefix. So we're saying if the value assigned to this particular attribute within my message body, if the value begins with image, then let the message go through to the subscriber, i.e. SQS. There's no real point in me talking my way through this syntax here. It's just kind of cut and paste, really. But if you actually follow the syntax, it's SNS dot filter or policy dot something. Same here, SNS filter dot policy dot something. SNS filter dot policy dot something. Now, in all of the cases, it's dot policy. Policy is actually just a static method. I'm using policy here, policy here. I'm using policy here, policy here, policy here, and eventually I'm using filter. I'm not using policy. And it's when you use the filter static method inside that, and it is a method. Okay, we're invoking nested methods here. Within the what the filter method needs is an actual filter declaration. Right. I don't know why I left that there. That should it's only confusing. But just to give you one other example of a message body-based filtering, and it's just, you know, I've just kind of picked it off the top of my head, really. It doesn't necessarily make sense. But if we zoom in on the message here a little bit, might just boost it up a little bit. And I've just picked out another property, which was, which one did I pick out? This one here. Let's supposing I wanted to filter on the basis of that particular part of the message. And let's say I wanted to say that only messages where the S3 schema version was equal to the string 2.0. We interpret this as a string rather than a number, but that's just by the way. Okay. So I want to do my filtering based on this particular property. How would I express that using the syntax that I've shown you there? My thinking here is if I give you enough examples, then you'll be able to write your own if you need to, which you may in the assignment. This is the filter expression for that. And again, we're using we're declaring our an SQS subscription. This is a reference to our some SQS queue that we have. And then we're configuring the subscription. Here's my one of the configuration options, filter policy with message body. And it's the same kind of syntax again. But now the S3, it's the value I'm assigning to this key, if you like, is sns.filter or policy.policy. Well, that's okay. And then this is the one that actually I want to home in on. And the value that it gets is of type sns.filter or policy.filter. And here's my filter. Right. Okay. So what I might do actually is I might just cut and paste those two bits of code because otherwise you're going to have to type them up if you do need to use them. I might cut and paste them and just put them into Slack so that at least you can paste them into your own code if you need to, and then start editing them. But, you just need to be careful that you have all of these closing brackets here. That's the annoying part of it, really. Just in passing now, this is nothing to do with filtering, but I would strongly recommend that you always use this property, always set this property to true. What this is related to is the SNS envelope. If you remember, I was talking about SNS can wrap a message inside an SNS envelope, and that just adds more to what eventually arrives at your Lambda function. If I just go back a couple of slides. So if I did have SNS enveloping going on, then there would be more stuff here. Sorry, there would be more stuff here inside in the body other than just the raw message itself. And we don't need that other stuff. So my advice is to always set that raw, whatever it's called, raw message delivery, always set that to true in any SNS subscriptions that you have. Okay, that's as much as we need to know about filtering. And we looked at that, it's okay. This is just, I actually just repeated a slide from the very beginning of this deck, but the whole reason we're talking about all of this stuff at all is we like to decouple our components that make up decouple the functional components, our functional resources that make up our architecture, i.e. the lambdas in our case. And we've looked at two techniques, or two resources, I should say, or two services that you can use within SNS, within AWS to achieve that. I just want to briefly talk about data streams as another part of this, part of the solution to this problem of decoupling, or this objective of decoupling. Now, this slide actually we saw way back when I started talking about serverless, and I started talking about lambdas, and I was talking about the different ways a lambda can be invoked. I was saying that a lambda can be invoked synchronously, asynchronously, and the third one was this odd one out, this kind of event sourcing approach. And it's actually this event source mapping, that's what's actually going on between SQS and Lambda. We know now that when we connect up Lambda with SQS, as in we make SQS the event source for our for triggering our Lambda. Then what actually happens behind the scenes is the Lambda service polls SQS periodically, and if it gets any messages from SQS, then it invokes our Lambda function for us. Well, and that is the essence of this event source mapping associated with Lambda. You can have that model also connecting a DynamoDB table to a Lambda, and that's what I'm showing you on the right here. And I actually, we've actually seen this slide before, but we're now in a position to see how we actually implement it, and hopefully it makes a lot more sense to us because we're familiar with SQS and Lambda talking. So the idea here is now I have a remote client here updating my DynamoDB table, but typically what you would have here is a Lambda that's actually updating the DynamoDB table. And I've got another Lambda down here, Lambda function, and I want it to execute whenever the state of my table changes. By that, I mean whenever a new record, or to use the language of DynamoDB, whenever a new item is added to a table, or if an item is updated, or if an item is deleted. I want this Lambda to be triggered. Now, the Lambda may not be interested in all of those, but we cannot, unfortunately, be specific about when this Lambda should be executed. We only want it to be executed. The most we can do is to say, execute this or trigger this Lambda whenever the state of my DynamoDB table changes. And the way it works actually behind the scenes is that DynamoDB, if you like, it keeps a log of all of the changes that happens to a table. We don't refer to it as a log, we refer to it as a stream in the language of AWS. So it maintains a stream of all of the state changes that have happened to a particular table. And that stream is essentially the equivalent of a queue of messages, if you like. And if in your CDK, if you make a connection between this Lambda and this table, and I'll show you the code for doing that in a moment, then what actually happens in at runtime is anytime there's a state change or a collection of state changes, because there could be a number. Well, sorry, I'll rewind. What actually happens when you make the connection is the Lambda service periodically polls the table, asking it, have you got any more new entries in your stream that I should pass on to this Lambda function? So again, it's a polling action that goes on between the Lambda service and the DynamoDB service. Essentially, the DynamoDB service is here, right? And the DynamoDB service checks to see, are there new entries in the stream associated with a particular table? And if there are, then a batch of those stream entries are passed back to the Lambda service, and the Lambda service passes them on to my Lambda function as a batch, which is, as I said, it's very like the way Lambda and SQS communicate with one another. So what I want to show you is how do we actually express this connection between a DynamoDB table and a Lambda function and the triggering of that Lambda function. And so there's two parts to it. First of all, in the actual DynamoDB table itself, so here's a DynamoDB table, you have to state that essentially you're saying here, I want DynamoDB to maintain a stream of state changes. If you don't include this property in the configuration of your table, then DynamoDB won't maintain a stream. So there'll be no stream that the Lambda service can poll. So that's what we're doing here. We're just saying maintain a stream. And as well, we are telling the DynamoDB service what it should put into each entry in the stream. And specifically here, I'm saying just put a copy of the new state of the item that was changed. Put a copy of that into the stream. There are other options as well, and I'll show you the other options in a second. So this now means that each entry in my stream or my log of state changes, there will be a copy of the record or the item that has been changed or added. And then so that's fine. That's our stream being maintained by DynamoDB. Down here then is how we connect up our Lambda function to that stream. And it's by means of an event source mapping, as we said. So this here is obviously a reference to some Lambda function that I've declared elsewhere in my CDK. I'm adding an event source to it. The type of the event source in this case is Dynamo event source, whereas previously we would have used SQS event source as the type. It's Dynamo in this case, and invariably this option is what we set it to. We only want our function to receive the latest entries in the stream that's being maintained by DynamoDB. So yeah, I wouldn't worry too much about this. You can just say this is hard-coded. There are other options as well, but we tend to ordinarily always use this one. So as a result of this and this here, we now have our function now is going to be this particular Lambda function is going to be triggered periodically by the Lambda service, and it's going to pass to it a batch of stream entries. And it's the exact same as with SQS. It is a batch that you're receiving. So you have to have some sort of for loop in the function. Now, I'm not going to show you an example of this, but of a function, but it receives an event. The event will have a dot records property more than likely, and the dot records property will be an array of objects, and each object corresponds to one stream entry. And you're going to have to just do some console logs inside in the function to find out, well, what is the structure of a stream entry? You're going to have to discover that for yourself, which is kind of what I'm saying up here, actually. And, we've lots of experience of doing that now throughout this module. So I don't have to show you an example of that. All I'm saying here is that when you declare the stream within your table, okay, you can specify what type of stream is it. And by type of stream, we mean what information should be put into each stream entry. And there are a number of options available to you. This one is saying just put the keys associated with the item that has been that the stream relates to, or that the stream entry relates to. Just put the keys. That could be the primary key and the sort keys if it has sort keys. If this table has sort keys, this one doesn't have, as it turns out. It only has a primary key, which corresponds to the partition key. So if I had set the stream's type to keys only, then each entry in this particular table's stream, each entry would just contain the partition key of the item that had been either modified or just added to the table. New and old means it puts a copy of the old version of the item and the updated version of the item. In other words, the current and the previous state of that particular item in the table. New image, I've already explained. Old image, it actually puts the previous state of the item into the stream record. So I suppose the safe bet is new and old, so that you have both of them, but it depends on what your Lambda is interested in. It may only be interested in the keys. It may only be interested in the previous value or whatever. Finally, okay, I've kind of already said this, the event object passed to the Lambda function. Oh yeah, sorry, this is an additional thing. So our Lambda function, if I go back to here, our Lambda function now receives a batch of messages, I suppose, really, where each message corresponds to a stream entry. And that stream entry will possibly contain, the new state of the item, the keys only, the new and old state of the item, as I've just been talking about. But in addition, the stream entry will indicate what type of operation caused the state change. Was it an update operation, an add operation, or a delete operation? In other words, up here, if I go back to here, what type of invocation was made here? Was the client trying to add a new record to the table, update an existing record, or delete a record? It may be important for the Lambda to know which of those operations caused the state change, as well as knowing what is the outcome of the state change and what was the previous value of the particular item, all of that. It may be also interested in knowing what particular operation caused the state change. And you will get that information inside in the event batch that's sent to the Lambda. And again, you just have to console log the event object and the entries within the batch to find where is that information actually contained within a particular stream entry or message that the Lambda receives. Right. That's it, really. That's all I want to talk about in relation to streams, and that's all I want to cover in relation to the module. But let's talk a little bit about the assignment specification next. I can pause for a second just in case there are any questions, if there's any lack of clarity in relation to this DynamoDB streaming stuff that I'm just talking about. No? Okay. So the spec, which hopefully you've had a look at. Now, straight away, I'm saying that we're really actually only interested in implementing something here, because as you know, if you scanned over the spec at all, you know that I'm giving you the design of an event-driven architecture for an application, and I'm asking you to essentially implement the design. So it's more of it's less of a design based assignment. It's more of just an implementation based one, and it is an EDA, event-driven architecture, and Maria, it's for an application that manages photo albums. I had bigger ambitions in relation to this, but I had to scale back on my ambitions. So it's difficult enough to see how this could be described as a photo album management application. But anyway, so be it. I'm giving you until this date for completion, but I guess the advice would be try and get it done before December 25th, because it's difficult to get back to these things after that. It's about 40%. The deliverables, again, is same as before, really. Just a text file containing your GitHub repo URL and a short video demoing the workings of it. I'll give you a README for this, for the GitHub repo. Again, it'll be fairly straightforward in terms of completing it. You must, as always, maintain a Git log of the evolution of this assignment. That's really, really important. And the starting base for this assignment is what you submitted for the event-driven architecture lab. That is your starting point. So this is the way I've decided to structure this assignment specification. I'm giving you 3 phases and it kind of depends on what you're aiming for in terms of a mark for this. If you're just interested in passing it, then you probably don't need to go any further than trying to implement phase 1. If you're aiming higher, then you're going on for phase 2, which builds on phase 1. And if you're aiming higher again, there's a phase 3, which builds on phase 2. So let's go back to phase 1. Phase 1, you see, from the event-driven architecture lab that you've submitted, you have already implemented a case where you can upload a file to a bucket. That bucket is the publisher of events to an SNS queue. And in the lab, actually, what you have is you've got two SQS queues that are subscribed to this topic, but we're slightly changing it. We still have one SQS queue, which is a subscriber. So you already have this link implemented, and you have this Lambda implemented as well, or we have a Lambda that is polling this queue for messages. The Lambda actually at the moment doesn't do anything. I think it just downloads. It downloads the image file locally, but it doesn't do anything with it. My plan was that having downloaded the image locally, it would generate a thumbnail version of it and then upload that thumbnail version to a separate bucket. Now, I've gotten that to work for myself, but I did it a number of months ago. And when I tried to replicate it more recently, I couldn't, because there's some switch somewhere that I'm just not getting right. So I've had to ditch that part of it. So the Lambda that you have at the moment in this position of our architecture doesn't do anything useful other than it's triggered by the queue. But what I'm getting you to do in this assignment is I want this Lambda to add a record to a table. And the record is going to be very simple. It's just going to have a primary key, where the primary key is the name of the file that was uploaded to the bucket. And it'll dig out that name from the message that it receives from the queue. So it's just adding a simple record or item to this DynamoDB table, where the item's primary key stroke partition key is the string corresponding to the name of the file. And there's nothing else. There are no other attributes. That's fine. As well, though, what I want you to do is I want you to have a DLQ linked to this one. And the idea is that if the file that's uploaded is not of type JPEG or .png, if it's some other file type or file extension, then I want this Lambda to throw an exception saying it's not interested in anything other than a JPEG or PNG. And so when it throws an exception, then that will hopefully cause the message to be put onto this DLQ. I want a new Lambda that is polling this DLQ. And what it will do is, for each message that's put onto the DLQ, it's just going to send an email via SES with just with an appropriate kind of message saying, I don't know, file x dot doc cannot be processed by this application or whatever, some meaningful piece of text. And that's it, really. So there's, if you like, oh yeah, the only other slight change is in the lab, this Lambda, you already have this Lambda, which is sending email, essentially kind of email confirmations that the file that you uploaded has been received. Okay. So that's still part of this architecture, but this Lambda was linked to an SQS queue, and the SQS queue was subscribed to the topic. Whereas now I'm saying just change it so that this Lambda is a direct subscriber to the topic. Right. So implementing all of that is my phase one of this specification. I'll just pause for a second in case there are any questions. No? Okay. Phase two, just to go back, sorry. I am going to give you an updated version of this lambda here, okay, which is actually, if I just page forward, there's a second page in the specification, which is this page. And what I'm telling you to do is take this code here and make that the starting code for this lambda here. Sorry. For this lambda here. If I just go off on a tangent for a second, then look at the implementation. What's important in the implementation is I'm actually throwing exception. Let's see, where do I have it? Yeah, this kind of code here. I'm what am I doing? One second. Oh yeah, like I'm actually checking here that the file extension is one of the two valid extensions. And up here, I'm actually extracting the file extension from the object key. Okay, so I'm giving you all of that code. And so if it finds that the file extension is, I lost myself again in the code. If it finds the file extension is not one of the ones that I'm interested in, then throw my exception. And there are other cases when I'm throwing an exception as well. But because we now know that throwing the exception is what will cause the corresponding or the associated SQS message to finish up in the DLQ. Okay, so I'm giving you that code. Now you will have to add some code here though. And the code that you add there is the code that writes to the table. But you know how to do that kind of write that kind of code. So that shouldn't be a difficulty. Moving on to phase two. Phase two, we add in a second SNS topic. We're also allowing the user to carry out two other types of actions. They can actually send a request to the bucket to have a file stroke object deleted. That when that event occurs, I want this topic here to receive a message to that effect. So this SNS, sorry, the bucket is going to be publishing to this topic. A bucket can have any number of what's the word I'm looking for? Oh yeah, event notification. That's the word I was looking for. This here. Right, back to here. Sorry, I had a blank there. A bucket can have any number of separate event notification attached to it. Okay, and so clearly here we would have two separate event notifications. Anyway, this event notification is going to be publishing to this topic. And I have this lambda is going to be a subscriber to the topic, this one in particular. And what it needs to do is it needs to delete the particular record corresponding to the file that has been deleted from the bucket. Okay, that's fine. Also, I'm saying a user can publish a message to this topic where the message has a particular attribute associated with it. And what the purpose of the message is to add a description for a particular image. And I want that description, which is just a text string, I want that description to eventually finish up in my table. So here they publish a message to my topic directly using, and later on in the specification, I show you how to use the AWS CLI to send a message directly to a topic. The body of that message, if I scroll down a little bit, the body is going to be like this. Simple enough. Name will be the name of the actual image file. Description will be my text. Should add the caption for that image. And I want this piece of text here, I want that to be added to the corresponding item in the DynamoDB table. The message as well will have an attribute, and where's the attribute? Here is the actual attribute, and I'm actually giving it to you. So you might cut and paste that into a JSON file, call it attribute.json, and then associate that when you publish a message to the topic using the AWS SNS publish command, which I think you've already done in the labs, or if not, I'm showing you how to do it up here. Is that where I show you? No, that's the delete one. Here I'm showing you how to publish a message directly to an SNS topic. Okay, so that means that this topic here has two different types of messages being sent to it from here and from here. These messages will have an attribute, whereas these ones won't. And so we need to have some filtering going on here, because I only want this Lambda to receive the messages associated with the delete operation. And I only want this Lambda to receive the messages associated with the publication of a message to the topic. And we know that this one has a particular attribute, whereas this one doesn't have that attribute. Okay, so you have to work out, how do I express my filtering here? But it is going to be attribute based. I can give that away. This Lambda, as I said, it will just do an update of the item in the table, and it'll find the key of the table entry, because the key will correspond to the name property in the message that was sent here. Again, if I scroll down to the structure of the message, here's the structure of the message, and this is where I'll find the name of the actual, the primary key of the table. Of course, if it doesn't have that, then it should just throw an exception. But we're not bringing in any DLQ into this architecture. So if there happens to be a failure, if they can't find a matching table entry, then just ignore it. Maybe don't throw an exception, because if you throw an exception, then the topic is going to keep asking, it's going to keep invoking the Lambda. And I don't really want you to bother about that. So if you don't find a matching entry, just ignore it and carry on. What else? That's it really. So the main focus is going on down here in phase 2. All of this stuff is still the same from phase 1. Again, I'll pause for a second in case there are any questions. Phase 3 is where we merge our two topics into one. So now there's 3 different types of messages being sent to this topic, and we've got to do filtering all over the place. And in some cases, the filtering that you do here will be message body-based filtering. You'll get away with attribute-based filtering in phase 2. That's one aspect of phase 3. Forget about this for a second. The other aspect of phase 3 is I want to have this table maintain a stream, and I want this Lambda to subscribe, if you like. Maybe I shouldn't use the word subscribe because that's specific to SNS topics, but I want this Lambda to be invoked with batches from the stream. This Lambda, though, is only interested in, initially, this Lambda is only interested in delete operations that have been carried out on the table. So it needs to look inside. As I was saying when I was talking about this a few moments ago, we've no way of, there's no kind of filtering that we can do here. So every time a state change, or sorry, for every state change that happens to my table, whether that be an add, an update, or a delete, that's going to cause an entry to be added to this table stream. And this Lambda is going to receive all of those different types of stream entries. So it needs to look inside the body of each stream entry to find out, well, was it a delete operation or an add operation or an update operation that caused a state change? And if it was a delete, then I wanted to send an email with just an appropriate text. File x.jpg has been deleted from the bucket. If you want to get very fancy and go for very high marks, then what you could do is take the functionality that this Lambda is performing, which is it sends an email whenever an object has been added to the bucket, whenever an image has been added to the bucket. You could merge the functionality of that into this Lambda. And that now means that this Lambda should send an appropriate, well, it should send an email with an appropriate message whenever a new item is added to the table or deleted from the table. I would make that the very last thing. If you're aiming for phase 3, try and get some of this stuff working first. And you may not get all of it. You may get some of it working. Then I would try and just get this Lambda to send SES messages for every delete operation. And the very last thing I would do is try and merge these two things, these two Lambdas together into one Lambda and get it working for both add and delete. That would be my advice. That's phase 3. I don't think that the Lambdas, none of the Lambdas do anything substantial. The difficulty or the challenge in this assignment is, getting all of these little components hooked up to each other, and the filtering as well is challenging enough. I think the body-based filtering is challenging enough because of what it will need to get the body-based filtering working is you'll have to have these Lambdas console logging so that you have a real clear understanding of the structure of the messages that they're receiving. And that will allow you to be able to express the filtering, which is what I was trying to explain there earlier on when we were looking at the S3 based messages. And I guess these are going to be S3 based messages as well, actually. But okay, I'm not going to say too much because I might only confuse myself and yourselves if I talk too much about it. Okay, that's phase 3. I am down at the very bottom here. I'm giving you some of the code First of all, I'm telling you, look, you need to use these imports in your CDK file. These imports relate to how you declare the stream associated with the table and how you make the connection between the Lambda and the stream itself. In other words, it's the actual imports that you need for writing this CDK code. Yeah. So I'm just giving you those because it could be difficult trying to find out what imports do I need. And as well, I am telling you that the actual Lambda itself, that's the one on the extreme right there of my architecture diagram. This is its signature. Its type technically is, it's another handler, but it's a handler associated with a DynamoDB stream. So this is the import that you should have at the top of that file, and maybe others as well. This is the type of handler. Although that's not really, it's not that significant. If you were, in general, if you were not too sure what type of handler is my Lambda, you could just give it the type. There is a type just called handler, which you would import from the same library here, and that would take care of everything. So it would take care of an SQS based handler, a DynamoDB based handler, an API gateway based handler. But if you want to be more specific, then for this particular Lambda, that's the specific type that it is. So we're talking about this Lambda up here. And sorry, did I get those the wrong way around? Okay, so that's sorry, these are the imports for the, sorry, no, these are the imports that you need for the CDK file, stack file. And this is related to the actual Lambda itself. Right. Where are we on time? 12:20. That's it, really. I don't have anything else to say to you. I'll pause again in case there are any questions. So I will be available on Slack for pretty well most of next week, but after that, it will be more difficult to get in touch with me. I probably won't. I may check on Slack maybe once or twice from the period after that. So if you can get an opportunity to at least study this specification and play around with how you might implement some parts of it, you don't have to get it absolutely squeaky clean. Try and achieve something maybe next week if you can. I'm sure you've got other demands as well, but okay. If there are no questions, I think I will leave it at that and enjoy the Christmas. All right. Bye-bye.